All right, lesson 228, electric motors and DC and AC single phase. So we're going to get a break from our transformers here for a little while. I'm not going to spend a lot of time in this video. I think the book does a nice job explaining most of these ideas. So I'll just touch on a couple things that I think are key points. There's just a little bit of math we're going to have to work on, but otherwise this will be a pretty short video for this lesson. Right off the bat, hopefully we're familiar with the motor nameplates by now. We did look at these a little bit in year one. But the nameplate of a DC motor provides important information necessary for correctly applying a DC motor with a DC drive. So there again, you're going to see various information. Shouldn't look too much different than what you see on an AC motor. Let's sort of look at a connection diagram. And this is really just sort of almost literally connecting the dots. But so let's say we want to hook this thing up to low voltage side. If we take a look, they tell us P1 connects to L1. There we see that connection, our first line going right to P1. Next we go down, we see that we're going to connect P2 with T3 and T8. So check that out. There's our connection between P2 and T3. And then there's our connection between T3 and T8. So that satisfies that section there. And then lastly, we're going to have T4, T2, and T5 connect to line 2. So there we see our line 2 connecting to T2. We got T2 going to T4 and T4 going to T5. Pretty simple. Again, just sort of connect the dots. Some of your homework questions, they give you 4 of those terminal strips, say which one's correct. It can look a little overwhelming, but just break it down, go point to point, connect the dots. Here's sort of the one bit of math we got to worry about here. How do we calculate the efficiency of a DC motor? This formula, this is a nice, elegant way to put it into one simple formula. I want to sort of break that down. We're gonna make it a little less elegant, a little more clunky, but I think it's easier to understand what the formula is doing if we look at it this way. So let's just take, for example, a 10 horsepower motor rated 31 amps at 300 volts. So we have to look at one point we need to note is that 1 horsepower is equivalent to 746 watts. Okay, keep that in mind. So we really are going to look at a rated wattage versus actual wattage. So we can calculate, wattage here using just some simple Ohm's law, right? If we say amps times volts equals watts, 31 amps times 300 volts equals 9,300 watts. So rated 9,300 watts. Pretty simple so far. Now let's look at it from the horsepower point of view. 10 horsepower, we said there's 746 watts in 1 horsepower, so 10 times 746 is going to give us 7,460 watts. Those are a little bit off. That's the efficiency portion of it. Nothing is perfectly efficient, certainly not motors. So we are going to have some percentage less than 100 of efficiency. So what do we do? Well, we simply take that horsepower wattage divided by the amps and volts wattage, and we get 0.802 or 80.2%. So this motor has an efficiency of 80.2%. Okay, and that's exactly what that formula above is telling us. When we see, horsepower times 746, well, there's that, right? And then we see I line times E line. Well, there's that, right? So just take this times this, that times that, and divide the two. That's what that formula is showing. But I break that down. I think it's easier to understand when you see it this way. And then the last thing we should point out, they do want you to reference Year 2 Annex R. So all the way in the back of your IEC textbook or your student manual is a glossary of motor terms. It's 3 pages, pretty useful terms. Just look it up, know where it's at. You're going to see these terms thrown around. That way it's not a surprise. And you can check them out for yourselves, see what they all mean. So once again, read through the textbook. They do a nice job. A lot of good general information on this one.